Yes, good afternoon, team. Good afternoon, all, and I wish you a very happy new year. Thank you for joining today's webinar on library management team designer. Uh, if you have any questions during the presentation or during the demonstration, please feel free to type in the chat box. We'll discuss at the end of our presentation. And this session and the recording will be soon sharing the recording with all the attendees. You can visit our website on the registration page. You can find the recording of this webinar. Now let us get started. Here is the agenda. In the first two sections, I am going to review the electronic components in Altium Designer and the aspects that constitute the most optimal component. I'll follow this with a discussion on approaches to create and storing components, and will touch up on component lifecycle considerations. Next, I will review Altium's library migrator capabilities, which allow legacy Altium file-based and database libraries to be migrated into an Altium rich workspace. Then I will provide a demonstration and wrap up the session with the question and answers. So, what is an electronic component? It depends on where the design is in design progress. Once a component is based on schematics, it's a variety of aspects that are critical to the entire design cycle. In the schematic stage, the component is represented as a symbol that has set of pins that are connected to other schematic symbol in order to represent the circuit design. In addition, the component having parameters such as value, accuracy, package type, etc. During the simulation, the corresponding models will be used to model the behavior of the component for detailed analysis. Once the components are forwarded to the physical implementation domain, they will be represented as a PCB footprints. The footprint may also contain the additional graphics in a mechanical layers, a 3D visual accept, and more. Throughout all design stages, an important aspect of component is availability and the cost. Parts procurement can occur anytime after the completion and approval of the schematic design and move in parallel with the board design. For procurement, the name of the component and the manufacturer are important. Also, you need to know which supplier sells them, what their cost is, whether they have them in stock, and whether they are still in production. The component impacts many aspects of the design. Let us review the approaches used in the Altium Designer to represent a component at different stages of the design process. In the first case, using separate schematic symbol and PCB footprint libraries, the symbol is a fundamental item and component parameters. PCB footprints, simulation models, and data sheets are associated with the symbol. The next generation approach usually is Altium 365 utilizes a separate component entity. You can think of this as a container of sorts for all aspects of electronic components, symbols, footprints, 3D aspects, etc. All the items I have discussed in addition of all these components aspects are stored in a workspace foundation and have their own unique life cycles and their user history. For example, schematic symbols can be applied to other similar components and cloned. Also, a component can be linked to a variety of part choice available from the variety of part vendors. And next, we are going to discuss about the composition of the perfect component. The component composition depends on the requirements of a particular component, but most often it contains the following set: a schematic symbol representation used in creating schematics and connections between components, a set of parameters which may be different for different types of components. Parameters can be used to display values on the schematic to search for components in the library. Also, they can be used to generate lists such as bill of material. A component also conveys a footprint that represents the component physical attributes on a PCB. In addition to pads, the footprint can contain additional graphics and mechanical layers. For example, to show the outline of the component or a courtyard which can be used in the layout. Ideally, a 3D model is associated with the footprint to reflect the physical size of, so that we can control the required clearance between the components on the board and can generate a complete 3D visualization of the board. It's important to include links in the component that point to data sheets and other supplementary information such as PDFs for the component, so that designers can quickly access the documentation when needed. If you are working with Altium 365 library, components have life cycles and revisions. Also, alternate part choices may be specified for a component such as capacitor of the same value but from several different manufacturers. What happened in practice? Do all components have similar composition? Quite often, designers encounter the following situation when creating a symbol. The parameter data is not complete. For example, a resistor or capacitor symbol is used, and the parameters are already completed in the schematic but not with the proper values. Also, when pursuing a rapid creation of schematic, designers may not associate footprints to symbols as they only need to create a schematics for a deadline. Incorrect footprints can be associated with the components already in the schematic, leading to potential errors. Most often, these result in a polarity mismatch between the symbol and the footprint, or the wrong footprint has been defined and the problem is detected data cycle at the assembly stage. Another common situation is that the designer uses a component from the library but which has often been used before, but in fact the part is not recommended by the manufacturer for new designs. That is, in the near future, its production will stop and it will be unavailable. Also, another common mistake is the name of the component, such as an IC missing the suffix code indicates the package type. From the point of view of the circuit designer, there is no difference in the symbol, but the perspective of PCB design and purchasing, the suffix defines the package type is critical. Fortunately, the procurement department will technically ask which one to buy, but sometimes they don't inquire. This is just some of the possible errors due to incomplete components. And if your component library is not accurate and complete, you risk inadequate errors and waste time in every project. The reason for incomplete component libraries can vary and is often rooted in super approaches to create and storing of libraries. And next we're going to discuss about is organize the how we can organize uh, components inside the RTM designer. The first one is we are discussing about the approach to create components. Often used in many companies is to create standard that defines the composition and rules for the creation of the both symbols and footprints, and everyone is required to adhere to these rules. The approach is good, but is not eliminate issues due to human errors. Also, it is useful to determine who can add a new component to the library. When anyone has the rights to create a component, the outcome may be less than optimum. A more advanced option used in large companies is assignment of a designated person to the role of librarian. In this case, it's important to understand how requests will be delivered to the librarian and what type of information should accompany each request. You need to understand how the person should send request for new component creation. Will it be letter, memos, emails, etc.? Also, the librarian can make mistake, therefore it's useful to have component checked by another person or the system. While they offer a considerable improvement, these approaches still do not guarantee 100% correctness of created components. Ideally, you need a system that supports a standardized component creation process with the ability to limit staff access to add components. The system should also include the capabilities for requesting a new component together with automated validation of the components against various criteria. The definition of life cycles are also useful for assuring incomplete or unvalidated components are not immediately deployed to designers. Yes, next thing we are going to talk about the more about the creating a components. This capability for organizing. component libraries is already available in Altium 365. You can create component templates for standardization for say resistors, capacitors, diodes, ICs, etc. The template can specify which symbol and footprint to be automatically associated to the created component. Also, a set of parameters that must be completed can be specified in the template. The creator will not be able to save the component without entering the data for all the parameters as defined by the template. This assures this vital data is consistent across your organization component libraries. In addition, the system has ability to manage writes as well as the function of for requesting new components, including routing requests to the designated team member. When you create a new component using such a template, the symbol and the footprint will be associated immediately. Also, there will be a set of parameters, but they will not be completed. To complete them, you must enter the full name of the component. If it is found in the database of the supplier, the component creator will be offered the option of automatically populating the parameter such as value, working voltage, package types, etc. When you save the component to the library, the component is through the mandatory checks such as missing parameters, upload separate footprints, etc. Such as centralized component library system with proper configuration will eliminate most of the errors that can be made when using a conventional approach to create the libraries and the management. Now let us discuss about the options for library storage. Libraries can be stored locally, especially when the design department is small. Everyone works with their own libraries. Periodically asking a colleague if have such component. They can also share libraries or periodically merge libraries into one. This is less than optimum approach for an enterprise. If one staff member gets sick or leaves, there may be a problems with access to the library that a person had maintained more often than not. Server libraries are used to specifying who can add component by accessing the roles. In terms of organization, libraries of symbols and footprints are often divided into component types, registers, ICs, diodes. Integrated libraries can be provided to users. However, the main disadvantage is redundancy. For example, when users create capacitors of different values and they actually have the same symbol. Another example is and SOD23 footprint. It can accommodate diodes, ICs, and transistors. It would be stored in three different instances in different files. If the manufacturer QA comes into us and has a footprint change, now we apply that all do we apply that to all equipment components across the organization? There is no version control for each component. If even if there is a version control system, it's impractical to trace the versioning of a single symbol within the library. Also, in such libraries, there is no awareness of the supplier, and it is impractical to track the use of components across the company's projects. This is a quite valuable if parents need to rapidly replace an incorrect, out of date or high failure rate components across the all the projects. A more advanced approach is to use database libraries. Components are created in a tabular form, which each row is a component. The row contains information about symbols and footprints, and from which library to use, and well as a set of parameters. The component is formed at the moment of insertion into a schematic, okay, from the database. If it is necessary to organize a version control system, the libraries are separate. Each separate footprint has separate files, so you can track the versions. The main disadvantage of this approach is that you need to deploy and administrate the database. For content addition of components to the library, users often deploy custom interfaces for populating the database. It is also necessary to install and configure a version control system to track changes. There is no integration to live electronic part supply chain data, and to achieve such integration, custom code must be deployed. In short, all these custom works takes time and often comes to at the expense of design time. Designers can be up and running with a freshly activated administrative workspace in less than 10 minutes. Often, designers only need to configure the component categories and edit templates. And if you have symbols and footprint libraries, they can quite easy to migrate into the RTM designer. Now let us discuss about the component lifecycle considerations. The life cycle of the symbols and the footprints can be different from life cycle of the component itself. For example, after a symbol footprint is created, it's checked and if it fall well, it's approved. If not, a long needed. It moved to obsolete. The life cycle component may include production stages. For example, if it is a new component and first it is used only in prototypes, promoting it to production life cycle state will enable the component to be used in organization-wide design and production activities. Lifecycle sayers allow you to manage the visibility of the components in the library as well as gathering their use in the projects. For instance, if a component is in the draft stage, it's at, not been approved or verified. Therefore, the draft component not be visible in the designer's components library. Now let's move on to discussing about Altium Designer Libraries Migrator. The library migrator has two primary modes, simple and advanced. I have listed the library types that can be migrated. The screenshot is of a simple mode and I'll cover this in the demonstration. Suppose we have a legacy libraries like as per the screenshot, these libraries can be uh, easily uploaded to the Altium 365 workspace by using this library migrator, which I will showcase during the demonstration. In the advanced mode, enables a variety of key capabilities, including library splitting, duplicate detection, and more as indicated in the list. This mode also allows you to combine source libraries that may be existed across the project or designer's workspace. It's a great way to consolidate any dispersed libraries. As is case with the other domain tools, with such as Actibom and the layer stack manager, the advanced mode of the library manager works in conjunction with the properties panel. Screenshots show the user ability to define designated folders, naming schemes, and reason name schemes for the item related to components such as schematics, symbols, and the footprints. Because some of the setup to map and migrate multiple libraries takes some time, the migrator gives you ability to save out its configuration so that it can be rapidly restored and as needed. I will show you the demonstration. Now let us jump into the demonstration of how we can manage and migrate your libraries the Altium 365 in an effective manner. We'll showcase with a live demonstration. I hope you are all able to see my screen. Here I have opened a demo project which we found the Altium installation, which is almost a 10 years old project which will be found in the Altium installation. Now you can see Altium Designer. I have connected to my workspace. You can see this is the workspace called as Altium 365, where you can able to manage your components in the cloud. By clicking on this globe symbol, it will take to the browser. From browser also you can able to access the your components stored in the your Altium 365 workspace. From here you can able to manage the uh, roles, responsibilities, and you can enable and disable the sharing settings of the process can be done here. You can see we have a different kind of categories available. Under this categories, if you click on the components, you can see all the available components. You can able to see here we have got different categories: amplifiers, audio type, data converters, miscellaneous, switches, and if you click on the capacitors, you can able to see the component name. Here we got the preview of the component symbol, footprint, and the data sheet, and the part as information. You can able to visualize the browser, and also can able to see the library health dashboard. This library health dashboard will let you know what issues we have components. See, we have got components of 11 having life cycle status issues, 92 components having stock issues, and we have got 61 of uncategorized components. You can see duplicate components and duplicate by names found 355. This library health dashboard will help you to easily find any issues in the components which you are managing the cloud. And also we have option to set the roles and responsibilities as I explained during my presentation. We will be setting your library, and librarian will be managing your data, and engineers will have only access to the libraries only meant for prototype of production, and draft components will not be having access. From here, you can able to assign the roles and responsibilities. If you want to add any additional role, you can able to add it, and here you can able to click on this button to edit, and you can add the people who want to make as librarian, and the people who want to make as a engineer can able to add from here by these roles and responsibilities. And also we have a life cycle setup. If you see the component life cycle, we have got a stage of life cycle. Is the uh, life cycle status. We have got five stages. One is planned, and then next is draft state. Draft state means based on the request the library has created, and it's in draft mode means it's not verified. Once everything is verified, it's moved to the next step of prototype. And if a prototype, if based on the feedback from your prototype team, then it will be updated to the production component, or again it roll back to the draft mode for the further modification. And from production, if it found any issues, again they will move back to prototype. But any issues if they found, they can mark it obsolete, and from the obsolete component they will move back to the draft mode. This is the life cycle of the component inside the Altium. Like this, to manage the life cycle as per your internal teams of feedback. Okay, now let us go back to the Altium designer. As I showcased the library where you can have access from the browser, you can access the same library within the Altium designer from panels explorer. The same libraries you can able to access from this explorer panel. All the categories, subcategories, component templates, all will be seen in this explorer panel. So now retrieving the data from the cloud. You can see in the latest improvements, you can able to get the library health in the Explorer panel itself. Earlier in the older versions of Altium, there is no option to get the library health in the Explorer panel. So in the latest version from I think from 21.9, they have added this library health in the Explorer panel. You can also see the same library health what you have seen in the browser. Will see in the Explorer panel. And as I am librarian, if anyone requests for parts, I could see the part request here. If I want to accept, I can accept, or I can able to reject the request. And if you click on these components, you can see I made my component as my company name, and you can see we got different categories of components, and you can see almost all the components are in tab space. Okay, no, it means it's all are verified, not verified, and is to be verified. And if you look at the models, you can see we've got the footprints and simulation files. If you have simulation files, also you can able to add the simulation files of components and have the symbols. And the beautiful thing here is if you edit the symbol or a simulation file or a footprint, the associated component also will get updated. That is the advantage of using the libraries in the cloud. Okay, if you change the symbol here automatically, where now it is mapped inside the your cloud library, it will get updated. Okay, now let us see how we can able to manage the life cycles of components. Let's go to the settings simply here. As I told you, the components drafts mode, it won't available to the users. How we can control is from here, the alternate workspace, go to life cycles. It will open the same life cycle which I have showed in the browser. Component life cycle, you can see here. If you click on here, if I say allowed to be, if I uncheck this one, allowed to be used in designs, then this component may not be available to the engineers. The same way, if the prototype also, if you don't want to allow others to see, if I uncheck this one, it won't be visible. Like this, you can also control the component visibility with the Ultimate Designer. And now we are going back to the our export panel. In the export panel, when I select the component, you can see we have got part choices. We are, I think this particular component which I have moved to register production. We have got a part choice of one. If you want to add, alternate for this component, you can just click on add. It will take to the supply chain, and then you can able to add the alternate part choices. for this component as well. Okay, okay. This is how you can able to manage libraries. And also, I just forgot to show you the templates. Here you can see we have got templates over here. You can see the component templates here. There are the component templates. Based on the template, when you are creating a component, I will show you how a template looks. Just click on edit, and you can able to set the your customer requirements like parameters, or if you want to pull every time a component symbol, you can able to assign here. This is an example, a capacity template. This is the life cycle which is taken from component life cycle, which is the demo. And you can see the component type automatically take a capacitor, and PCB library we didn't assign it, but schematic library whenever a component is been uh, selected as a capacitor, automatically this template will be assigned and automatically will add the symbol. As you told, the capacitors, if you are using a non-parallel capacitor, the symbol remains same. With along this template, there is no need of drawing the symbol multiple times. Once you create and assign to the template here, automatically when you are picking the template category, when uploading the library to the Altium 365, it will pick this particular template. And also we have the parameters. What are parameters required? Suppose let us take example of value. It should be in farad. You try to enter a ohms, apart from the farad, the tool won't let the component into the your cloud workspace. And also we have got some kind of text. Suppose voltage means should be V. If you try to enter the amperes other than the voltage, sorry, if you try to enter other than the voltage, the tool won't get the component. Like this, you can able to edit the templates, and you can start creating your components, or you can start migrating your components inside the RTM designer. Okay. Now let us see how we can upload your legacy or file-based libraries into the RTM each workspace. To do so, uh, we have already a library available here. You can just go to file. I can just click on library migrator. I can able to add the library which will be available from your local computer. Or if the integrate library is a part of your project, just start the integrate library or a database library or a basic library or a schematic library, and library migrator. When it's a library migrator, you will get a one library migrator window, which is a simple mode. Now it is analyzing the design, what the components are there inside the design, is analyzing it, and it will display, it will automatically assign the categories based upon the comments and the description. It will also try to assign the categories like capacitors, resistors, transistors, uh, integrated circuits. You can see automatically it has assigned all the component from 37, and out of 37, 8 it can able to categorize those components. You can see I got symbols and footprints and simulation files. It found one. And this is a simple mode. If you don't want to assign these uncategorized components, you can just simply click on migrate. It automatically migrate the symbols. But we have to make sure this uncategorized components we have to assign it to the appropriate category. For that, just we shift to the advanced mode. In the advanced mode, we can see the components will be open here. The capacitors, 5 numbers, and the ICs, fuses. And if you look at the uncategorized components, we have got few of the components which are too unable to categorize it based on their thing. Now we have to set some rules. By this library speed wizard, we will add a one rule stating that a transistor, okay, and the designator is Q question mark, okay. And if you can see, we have got I'll cancel it. You can see here we have got 8 components. In this is the by seeing the part number and by seeing this one, you can identify the family of transistor. Now how tool will understand? We have to use some certain rule for that. For that, click on library speed wizard, and add take the transistor, and enter a Q question mark, okay, and update. You can see automatically a category has been created transistor, and this particular component which was there uncategorized, it moved to this one. If we have the library migrator configuration file like this, Okay, you can able to automatically import, and you can able to directly categorize all the components with a single click. Once your migration and categorization is done, I'm not going to categorize this. Just click on validate. This validate helps you to compile the project. I think there is a parameter mapping issue for the capacity destroying. You can see when you validate here, it is saying this particular component having parameter value issue, and this particular component also having some issue like this. You can see simulation parameter skip. Okay, you can like this. You can able to get the violations. By reading this, if you are okay with this violation, you can able to migrate these symbols, or you can by excluding those. Yes, I already know the error. My interest here is how we can validate and how we can migrate. But error is seriously we have to look at it. But we don't have that much time to look at the error. That's why I just migrated in that symbol the my cloud Altium workspace. Now it is in process. In the meantime, if anyone having any questions, please do type in the chat. In the meantime, we can discuss on the same about the this cloud component management, which is a very organized process. And as I told you, if you change the one symbol where all this component is there in the workspace, it will get updated. Yes, now it's almost completed the process. And the advantage here is who are suppose if your library is in the cloud, the team who are all connected to this workspace, they can able to access the same. Now in the current situation, we are working from home. Is it difficult to connect everyone to the your office server and get in the library? But here, if we have the workspace in the cloud, then there is no need of connecting the server, so that they can simply connect to the workspace. They can able to add it. If you look at the export panel, as I know, I have my components also loaded. It's difficult you to showcase. Let me show you a component type transistor. Maybe I'll try to showcase you uh, a date as column. I'll try to give a release date. If enable, like you see the date by date, you can able to figure out. See here, this is a particular component which I have released it today based on the timestamp. This is a component, and life cycle you can able to see it's in draft mode, and part choices as it's not available, you can able to add the part choices. Like this, you can able to migrate your libraries to the cloud, and the same you can able to access from the Altium designer. Okay, and if you are trying to migrate the same library one time to our site, if you're trying to migrate, the tool will flag an error that it found some duplicate. You can see here the error message. You can see here. Uh, some duplicate component found. You can see duplicate, 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 duplicate. Okay, like this error you will get when you're trying to upload a component same of multiple times. Okay, we'll get a warning based on the component rules set we kept. It will flag that error. Okay. This is a help you to overcome the uploading the multiple duplicates of components to your cloud library. This is about the all about the library management in the artificial workspace in an organized manner. Now we are open for the questions. If anyone having any questions on the Altium 365 cloud library migration and component creation, template creation, please do type in the chat. Yes, I think seems to be no one having questions. If no one having questions, we will end our session for now. And thank you very much for joining our today's webinar. And we'll meet you in our next webinar, which we're going to discuss about the latest functionality in December 22. And stay safe. We'll meet you in the next webinar. Thank you all.